Hi class, today we are going to cover section 2.7 geometric proofs. This is also called segment addition proofs. The learning objective is that we will justify statements involving segment congruence and segment addition. Remember these two concepts. The first one says segment AB is congruent to segment CD. This means that two line segments are congruent. The second one says the measure of AB is equal to the measure of CD, or you could say the length of AB is equal to the length of CD. This means that two line segments' measures are equal. So they look very similar, but they're a little different. So now let's talk about the definition of congruence. The definition of congruence says if two line segments are congruent, then you can say that their lengths are equal. It also says if two line segments' lengths are equal, then you can say the line segments are congruent. So we will actually use this definition while we're writing proofs. The segment addition postulate. The word postulate is just a statement that is assumed without a proof. So, we've already done segment addition. Segment addition of postulate is something we're going to use within proofs. So, if C is between A and B, then you can say that AC plus BC equals AB. So you can add the two smaller segments to get the big segment. This is something we did in the first chapter. This is just a reminder. This is also sometimes called betweenness of points. So let's try our first segment addition example. Use the figure to solve for x given JL is 62. So first we're going to write our segment addition equation. JK plus KL equals JL. Then we're going to substitute in our values for each. JK is 5x, KL is 8x minus 3, and JL is 62. We combine like terms on the left-hand side to get 13x minus 3 is equal to 62. We add 3 to both sides to get 13x is equal to 65. Then finally we divide by 13 on both sides to get that x is 5. Now I want to justify each step, because this is something that we are going to have to do in our proofs. So the first step is just the segment addition postulate, saying that you could add the two smaller segments to get the big segment. The next step is substitution. We substituted in those values. Then on the next step, we combined like terms. Then we added over the 3. And then finally, we divided by 13 to get our answer of 5. So if I was going to write this as a proof, we would have a given statement that JL is 62. We would have our picture, and then we would be proving that x is equal to 5. So, where I just had you justify each step, that's going to be your reasons, and over here under statements is your steps. So let's try to write a proof. Here's our picture. We're given that AC is equal to 6, and we want to prove that CB is equal to 21. So your given statement always goes first. Your reason is always that it's given. Notice that I marked my picture with my given statement that AC was 6. Next, since AC is 2x and it's also 6, we're going to set those equal. That's just using substitution because 2x is 6. We divide by 2 on both sides to get that x is equal to 3. So that was using division. Then we use substitution to figure out what CB is, because we're trying to prove that CB is 21. So we're going to plug in 3 for x. That's using substitution. Then we get that CB is equal to 21 by evaluating that expression. 8 times 3 is 24, minus 3 is 21. Yay, we've done our first segment addition proof. I'll see you guys in class.